We are here to show a presentation on the topic mathematics in nature. We are starting our presentation with a big statement that everything in this universe is mathematics. Some of you may not accept it, but I'm 100% sure that after our presentation, you will also agree with us. Mathematics is directly proportional to the beauty of everything. Without mathematics, there is no beauty. For beauty to come into place, there should be some proportion in which it should be made. Look at a flower, or look at a leaf, or take a human being itself. For him to be handsome, he should have some kind of proportion. If his body is not proportionate, can we say he is handsome? No. And what is mathematics at the end of the day? Mathematics is just a language in which we express. It can be in the form of shapes or diagrams, or it can be in the form of graphs or numbers. Everything in this beautiful nature can be derived mathematically. So here we are starting our presentation. Mathematics is all around us, and some of the legends or the greatest mathematicians have drawn their conclusion by looking at the nature itself. Look at the way the father of geometry, Euclid, has said about mathematics in nature. The laws of nature are the mathematical thoughts of God. It's synonymous to what we have said earlier. Everything can be derived mathematically. So, the first statement I want to begin here, I want to start off with is, nothing is invented. Nothing can be discovered. It can be just identified. So today also we have observed certain ways in which mathematics applies to the nature, and it's trivial to everyone and it's axiomatic. So mathematics can be observed in the nature in the following ways. It can be in the form of geometrical shapes, it can be in the form of symmetry, it can be in the form of Fibonacci spiral, the golden ratio, and fractals. If you go deeper and deeper into it, you will come to a conclusion that mathematics is nature and nature is mathematics itself. Geometrical shapes. It's the most common way in which we see mathematics around us. Let's look at the first one, shapes, perfect shapes. There are a lot of three-dimensional shapes around us. We don't actually name all of them, but we give certain names to those shapes which look peculiar. They are of a typical kind. So that's why we give a name to them. And that's what applies here. Look at our earth. It's a trivial example. Our earth can be considered as a sphere, but it's not a perfect sphere. Its top and bottom is a kind of a little flattened, and it's bulged at the equator. And why is it done so? It is to minimize the pull of the gravity on the outer edges. Wow, how nature plays with us. And inherently, we are accepting the mathematical thoughts of nature itself. Shapes can be seen in the form of polyhedra. For a beehive, close packing is important to maximize the use of space. Hexagons fit most closely together without any gaps. So hexagonal wax cells are what bees create to store their eggs and larvae. Hexagons are six-sided polygons, closed, two-dimensional, many-sided figures with straight lines. And the animals and insects around us, they don't know the mathematical concept behind it, but still they are using it. There is where we can see the mathematical magic, and we are deriving something useful from it. Yeah, it's most commonly seen. It may not be explained. It can be seen in the form of cones, and most of the volcanoes that we see around us is in the form of a cone. Parallel lines. It is of a peculiar form. So parallel lines a line, the parallel lines are formed when two lines are equidistant from each other and they don't meet. Then they stretch out infinitely, and that's called parallel lines. And parallel lines can be observed in the nature. Most of the sand dunes are in the form of parallel lines, and even they serve as boundaries of many countries and states. Fibonacci spiral. I think this is the most important part where nature plays with mathematics.